So a lot of the news yesterday was using the word limitless in their headlines, talking about energy. And we were told a lot that clean, limitless fusion energy is just around the corner because there was a breakthrough. I got bad news for you. While there was a breakthrough, and a very important one, it's still not a limitless power source, and it is not just around the corner, and there's a good chance it may never happen. So let's put our heads around some of what happened. So the breakthrough was the National Ignition Laboratory ignited a fusion reaction that generated more power than it took to ignite. It generated 3 megajoules of energy from 2 megajoules of laser power used to excite the hydrogen up to temperatures needed for ignition, which is amazing. This is something scientists have been working towards for over 50 years now. Yes, half a century, more, closer to 70 years. And great, wonderful, but it wasn't 2 megajoules of power. It took 300 megajoules of power to operate the lasers that generated 2 megajoules of power. So rather than getting more power back than they put in, they actually only got 1% of the power they put in, if you look at it in genuinely useful terms. So this is a long ways from being a true self-sustaining reaction. Now, it's not even a sustaining reaction. It ran that much power for a fraction of a second. The word megajoule is also not very well understood. It sounds like a lot. It sounds like a big number. It sounds like a megawatt. Well, it's not. 3 megajoules of energy is the equivalent of about 0.8 kilowatt hours of energy. That'll run your phone for a day. That's enough energy to drive a Tesla about 3 miles. By comparison, the average American household uses 29 kilowatt hours of energy a day. So, and that's just electricity. That's not counting, home heat that's coming from gas or coal or oil. That's not counting fuel for cars. We are nowhere near what needs to be done to deliver this power continuously, reliably, at scales large enough to contribute seriously to the electric power grid. This isn't free energy. And while, yes, the energy comes from hydrogen, it's not just any old hydrogen. Fusion reactions rely on special isotopes of hydrogen called deuterium and tritium. Deuterium is really rare. Only a tiny fraction of a percent of hydrogen is actually deuterium. So yeah, sure, we can just run seawater. Once you separated out the magic seawater from the rest of the seawater. And tritium is a tiny fraction of the amount of deuterium. So it's extremely rare. And pulling usable amounts of it out of our available water is a tremendous engineering task. Far, far beyond anything that we've done so far. Now, this is not to say that this is hopeless. or that we shouldn't be pursuing this. This was a tremendous breakthrough. We absolutely should be pursuing this. But we can't count on it. It may never happen. It may not happen in our lifetimes. It probably won't happen in my lifetime. And we have a carbon problem right now. We are continuing to use coal and oil and natural gas, and it's causing the earth to heat up very rapidly and very dangerously. It's a threat to human civilization. We've got to solve that problem now. And there is a solution, and it's a fusion solution. And that solution is solar and wind power. Solar panels are running off of fusion energy. It's just fusion from the sun, not fusion from our own godlike powers. Wind is driven by the atmosphere being warmed by the sun. So again, it's fusion power. And they work. They work now. They work now, and they are less expensive than any other power source right now. They are less expensive than fossil fuels. They are less expensive than traditional nuclear power, which unfortunately is very expensive. They work. And they're not continuous, which means we need batteries or hydrogen or other storage to make power when we want it, not when it's being generated. And yes, that's an efficiency loss, and it's expensive, but it works. It's just a question of cost. This is all a question of cost in the end. Fusion may not ever work because it turns out to be too expensive, just as nuclear fission never really caught on as a primary energy source because it's too expensive. But you know what's expensive? Cities falling into the ocean, crops failing, people dying. That's expensive. And that's what we're facing right now. So don't let the breathless headlines distract you from the important work that needs to be done now to decarbonize the grid with the tools we have now, which are wind and solar energy.